Assalamualaikum and salam sejahtera. My name is Mohamad Afif Fakhri. We are from Group 8, want to discuss the question 3. We are required to construct and stimulate the single-phase full bridge inverter with SPWM control technique. That we can see at the question 3, we have give the Vs is 120 volt. The semiconductor power device is used is ideal IGBT, and we have to put at the single phase circuit is with resistive load and inductive load. This is the circuit. The Vs is 120 volt. The resistive load is 10 ohm and the inductive load is 0.025 Henry. And we connect with the other LGBT, four other LGBT that we rename from S1, S2, S3, and S4. The single phase inverter that we know is the if by using positive half cycle, S1 and S2 will be turned on, but S3 and S4 will be turned off. During the negative half cycle, S3 and S4 will be turned on and S1 and S2 will be turned off. Okay, at the VR, we use is 170 volt and the frequency is 50 Hz. We get the 50 Hz if by using MF equal to FC over FR. We know that switching frequency equal to FC. So 500 Hz is FC. So it's FR equal to FC over MF, and we get that the 50 Hz. We connect that at the multiplier. For the VC, we know that the VC is 170 that we get from MA equal to VR over VC, and we multiply by 2 because it is 1 to voltage peak to peak. The FC, as we know, and at the question is 500 Hz. We put there 500 Hz, and we connect together with voltage reference at the comparator, and comparator will connect at Q1 and Q2. Q1 is either LGBT for S1 and S2, and Q2 either LGBT for S3 and S4. We connect with Q2. We connect Q2 with NOT gate because the type 1 on the question is bipolar. So we must put NOT gate at Q2.
Assalamualaikum, I'm Naufal. So I want to show you the result measurement, the measurement for semester result for question 3. So for question A, we want to simulate the waveform for VR and VC. So as you can see here, for VR and VC, the blue one is for VR for the modulating signal, and for the red one is a carrier signal. There are few characteristics for modulating signal. Modulating signal is usually give sinusoidal waveform. This is sinusoidal waveform, and carrier signal give the M shape, triangular. So this is a bipolar because it gives you M shape. So for question B, we want to see the PWM and PWM1, which is right here, and so this is the result for PWM1 and PWM2. As you can see here, PWM2 is inverted from PWM1. And for question C, we want to see for B out. So this is B out output. It is right here between the load. So we see here the result for B load and PWM1 is the same. This is because it is depending on the waveform for VR and VC. If the modulating waveform is reached to the max, the width for the V out and PWM um, is bigger. Therefore, the pulse will become bigger for the principal for bipolar PWM. If the sinusoidal is higher than the triangle, it will bigger the negative BDC at the out form, and it will turn on the S1 and S2. And if the modulating the sinusoidal is lower than the triangle, the width become bigger and it will turn on S3 and S4. So that's all. Thank you.
Assalamualaikum dan selamat sejahtera. My name is Ahmad Firdaus and I will continue to obtain the result of D, E and F. So for D, we will find the output current I naught. So to do that, we will run the simulation circuit and then we will choose I naught since we want the I naught. And here the result of the I naught of bipolar single phase full bridge inverter with ideal IGBT. So next is RMS measurement of a complete cycle of I naught. So once more, we want the I naught. So we choose I naught. So to measure the RMS, we'll click here, measure. And as you can see here, we choose RMS. I already choose the result of RMS, but in one complete cycle. So we will adjust here from 4 to 4.06. Okay, so here the result of RMS of I naught, which is 4.16479 ampere. So next is the harmonic spectrum of V out and R out. Set the s-axis as follow. Scale is linear and range from 0 to 1 kilohertz. To do that, we again run the simulation, and we'll choose I naught and V naught, which is I out and V out. So here the graph in time domain, but we want it in a frequency domain or harmonic. So we will perform the FFT. FFT is fast Fourier transform. So we will change the s-axis as a requirement from the question, which is 0 to 1000, and the scale is linear. So here the result of the question F, which is harmonic spectrum. So that's all for me. Thank you.